In this problem, we start off with the function fx, which starts off at fx equals 0. And then we're given q queries in order. And there are two types. In the first type, the very first number we see would be a 1, and we're given a and b. And what that does is we take our previous function, and then onto that, we add x minus a plus b. And then if we have a type 2 query, then what we have to do is we have to output the minimum value of x. Sorry, we have to output x such that it will make fx as small as possible, and we also have to output what fx is. Okay, so let's break this down by looking at one example, like here. So we're given this as our input, and this should be our output. So let's see how we go from the input to the output, right? Okay, so we know there are 4 queries, and at first we know fx equals 0, right? Okay, now we start. So this is of type 1, and we know a is 4, b is 2, right? So then fx, we now change it to what it was before, so that's just 0 plus what is it? It's x minus 4 plus 2, and then we have to output what's the minimum x, and sorry, the lowest value of fx and what x causes that, right? So in this case, when x is 4, it will create the lowest value of 2, right? Because when x is 4, this becomes 0, and then 0 plus 2 is 2. And if x were any other value, then let's say x was 5, then this would be 1, which would be bigger than 0. So that'd be an issue. So it's 4 and 2. And then the next we're given 1 and minus 8. So it'll be plus x minus 8 minus 8, right? So what we can see are these b values are outside all the absolute values, right? So we can handle them on its own, right? So let's change this to become minus 6, right? So our overall b value is going to be 2 minus 8, which is minus 6, right? And we know for the answer that we get in this, that value is the, sorry, to reword that, what we want to do is we want to make this as low as possible because b is always fixed, right? And to minimize this, the answer would be 1. And then here we'd get 3, sorry, this should be 1, my bad. Yeah. And then here, 1 minus 1 is 0, 1 minus 4 is 3. So then we'd get a value of 3 here, 3 minus 6 is minus 3. And the value of x we used was 1, which is what we got here. So to make this, if you look at all the absolute values of all the a's that we get from all the type 1 functions, the way to minimize this output is by always using the median value of all of these numbers, and this is a very well-known problem, right? So essentially what we do is we look at all the a values, and we know that the value that makes this as small as possible is the median of all the a's, right? So the median of 1 and 4 is going to be 1, because we will just look at the if it's 1 and 4, it doesn't really matter which one you pick as long as it's in the center. So even if you picked 4 here, right? 4 minus 4 is 0, 4 minus 1 is 3. So that still stands, right? So as long as you pick a median value, this sum will be as small as possible, and the b is always fixed. So that's essentially how you solve the problem. We always want to output the median and then solve for f where x is a median, and then we output that also. Okay, so how do we do this? So if we look at our here, right, q can go up to 2 times 10 to the 5, and a and b can be it's int for sure. And since q is 2 times 10 to the 5, and we can have as many type 1 and type 2 functions as we want. Then if we just have all the a's in a list, and then we keep on, and then we sort it, and then we find the middle element every single time, we'll go over the 2-second limit, right? So the way that we handle this is we create two sets, in which one set has all the numbers that are low, and the other set we have all the numbers that are big, right? And how we'll make these sets is that the lowest set should always be as big as the biggest set, or one larger than the biggest set, and that's how we know we have split all the numbers equally. And then we just find the median value, which in this case would be the last value in the low set. So this may sound a bit confusing, so let's just try and code it, right? So we have a multi-set of longs, and we call this low and high, right? And let's keep track of the sums in low and high, right? Okay, so let's create a function called balance, which deals with making sure that the median is always the last element in the low multiset. So we have a function that's void called balance, and here what we do is, so while this is true, while this is true, we'll have int ls equals low dot size and hs equals high dot size. Oh, whoops. Okay. There we go. So if ls equals hs or ls equals hs plus 1, we break. All right. So in the test case here, right, we first start off with 1, 4, 2, right? So our a value is 4, right? So let's call this low, and let's call this high. So at first I would just, since it's empty, we will just insert the first one, so 4 over here. Next, we see 1, right? Is 1 less than 4? Yes, let's insert 1 into low. Then we check, does this hold true? No, because low dot size is 2 larger than high, the size of high, right? So then we have to change it so that the 4 goes over here. So how do we do that? We can say if ls is less than hs, which is actually not true in this case, but we'll deal with that. So let's deal with the other case that we have right now, right? So right now, let's take a iterator v, and let's call that low dot end. So we look at the very last element in low, and we insert that into high, right? And then that means that the sum of all the numbers in high goes up by v, and the sum of all the elements in the low multiset goes down by v, right? And then in the very end, we just take this element out of low, right? So we're like, okay, this is larger than this. We'll take the largest element in this, which is 4. We'll take that out of here, and we'll plop it in here. Whoops. And we'll leave it in here, right? And then we also change the sums. So now the sum of this is 1, and the sum of this stays 4, right? So now that we have done this, we go through the loop again, and then we check, okay, is the size of low the same as the size of high? Yes, we break, and that's how we know the low set and the high set are in a manner in which we want it, and we can just always look at the last element in low to get the median. So the median here is 1, which is exactly what we want, right? Okay, so we handled that case, and now if high is too big, if it's like 1 and 4, it's the same logic, right? We look at the smallest element, and then we shift that from high, and we bump that in to low. Okay, so let's deal with that. So again, auto v equals high dot begin, low dot insert v low sum plus equals v, high sum minus equals v, and then high dot erase v, right? And so that deals with that. So now we can balance our sets properly such that the last element in low is always going to be the median value which we want, right? So now let's try and solve it, right? So we're given q and then q queries. Okay, so we're given q. Let me go, and let's also keep track of the b sum, right? Because we know that the b value doesn't really matter. We just need that to output the value of fx, right? So let b sum equals 0, and then for q we are given sum n, right? So if n is 1, so we know this is a type 1 function, then we are given a and b, right? Right, if it's the type 1 function, we are given a and b. So first and foremost, in b sum we add the value of b, and then we need to add a into these multi-sets, right? So let's do this case by case. So if low is empty, right? I think, yeah, I can just do low dot empty. Then what I can do is I can low dot insert a, and then low sum plus equals a, right? And then, so that's if low is empty, right? Then in the next case, when low is not empty, we look at the current median value, right? So so we had to check if, so let's just call it median, right? So okay, a better word would be previous median, right? So our previous median is going to be this. So if our previous median value is bigger than or equal to a, then we would insert that into low, right? So we'd insert a into low, and then low sum plus equals a. Otherwise, if our a value is higher than our median, we'll insert that into high as for now, right? Otherwise, high dot insert a high sum plus equals a. And then after all of this, so now that we added this new element into either the high or the low, we have to balance the entire, we have to balance both the sets, right? Because what if there are now too many elements in high, or there are too little elements in low, or right? So then we balance everything such that the median is now the last element in low, right? So that's what we deal with when we insert an a and b. So sorry, when we deal with the type 1 query, right? Now if it's a type 2 query, so first thing first, we need the median, right? So auto iter equals low dot end minus minus iter, then the median is just this value, right? So then so now we have the median value. We need to find out what the f of x value is with this median at this stage, right? So we know we add the b sum together, and then it's median times low dot size minus low sum plus high sum minus median times high dot size, and then we just see out median Cons and the okay, where do we get our bugs from? So multi-set. Oh, whoops, that should be like that. Oh, auto V. Oh yeah, you should be V. You should be V. Oh wow, okay. So let's see if this works for now, and then I'll just go over the last logic one last time. Yep, 4, 2, 1, minus 3. That looks good. Minus 1,003. Yep, that looks good. So let's just go over this last section one last time. So why is this the answer? So the reason that I made a low sum and a high sum, so in O of one time, we can now find out what is the sum of all the elements in the low set and what is the sum of all the elements in the high set. And we know for a fact that all the elements in the high set are larger than the median, and all the elements in the low set are as big or smaller than the median. Right? So why does that matter? Right? So when you're finding the absolute value, rather than use the abs function, instead we know that here, since all the elements in the low set is less than our median, we can just do here. So let's say our median is 6, and in low we have 1, 2, 3, 4, 4, 5, like that. Right? So now we're doing x minus a, right? And so we're just finding the absolute value of this change. So 6 minus 1 is 5, so it's basically 6 minus 1 plus 6 minus 2 plus 6 minus 3 plus so on and so forth, right? So this minus this minus this. So what we can do is we can just sum all these up, because these are all less than this. So we know this is going to be, if we leave the median on the left side and then we subtract all the a's here, we know this value is going to be bigger than 0, right? So now we know all these elements it's going to be minus, right? So if we add all these things together and then we subtract that by this times the number of elements we have in this, that's the same thing as doing this minus this plus this minus this, right? Because then this breaks down to, in this small case, this becomes 6 plus 6 plus 6 minus 1 minus 2 minus 3. So, and like plus more 6's, and then you, so yeah, here we're just looking at this, right? So there are 3 elements here, so we need 3 6's. Okay, that's good. And then 1, 2, 3, we just sum all of them up together, and we know this because we say something called low sum, which we change properly. Oh wow, that's low. So yeah, so we get this value in O of one time, and we get this value fast as well. I think it's O of 1, if I'm not wrong, right? Because it's just the size of this times the median. And the same logic, if we have like high, right, and this is suddenly 7, 8, 9. 7, 8, 9, right? So now we know if it's high minus this, only then will the value be bigger than 0, right? So let's change this to become, so I will do now 7 minus 6 plus, oops, plus 8 minus 6 plus 9 minus 6, right? So using the same logic, this becomes 7 plus 8 plus 9 minus 6 minus 6 minus 6. So if we know the sum of all the elements in the high set, and then we subtract that by 6 times the number of elements in this, then we will know the value of fx with all the elements in the high set. So now that we know the value of fx for all the elements in the low set and the high set, we get this and this, then we add all of that to b sum, and that's how we get our answer. And this should work. Yeah, okay. and voila,